For robots to walk down the evolutionary road we've already traveled, they're going to have to learn to move on their own. What happens then? Will they evolve complex brains like ours? Robot builders Josh Bongard of the University of Vermont and Hod Lipson of Cornell University are trying to answer that question.
Increasingly, we see that interaction with the world, with the physical world, is important for intelligence. You can't just build a brain in a jar.
Hod and Josh's goal is to build a machine that's smart enough to learn how to move around all by itself. They've created a menagerie of strange robotic forms along the way. But their work starts with a computer program designed to evolve robot bodies. It simulates various body plans and then tries various strategies to get them to move.
Okay, so let's walk our way through, no pun intended, an actual evolutionary simulation. So in this case, we've told the computer that we want a robot that has 2 legs, but we want the computer to figure out how to get the robot to orchestrate the movement of the robot's legs. And here we see something a little bit surprising, that evolution hasn't discovered the solution that we use. Sometimes when we run this evolutionary process, it produces something familiar, like walking, and in other cases it produces something that's not familiar, something we wouldn't have come up with on our own.
It's survival of the fittest, or perhaps the least awkward. Just as Mother Nature selects generations based on their ability to survive, so does the simulation.
The computer deletes the robots that aren't doing a very good job, and the computer then takes the robots that are doing a slightly better job and makes modified copies of them, and repeats this process over and over again. And after a while, the computer starts to discover robots that, in this case, are able to walk from the left side of the screen to the right side of the screen.
This is evolution on steroids. What took Mother Nature millions of years takes the computer just a few hours. Overnight, the computer tests thousands of generations, and eventually, it produces a robot that meets the goal. When the simulation makes something that looks particularly interesting, Hod and Josh take that body plan and build it. Now they can test whether the strategies for moving learned in simulation work as well in the real world.
So this robot is called the Quadratot, and it's basically a robot that learns how to walk using evolutionary robotics techniques. And so what we can see here is a particular example of how this robot learns. This is one of the earliest gaits that it did, and we can see that it's not moving very far, very fast. It's kind of like a child doing its very early behaviors of crawling. It's trying out different things. Some things work better, some things work less well, and it's taking that experiences and learning from them and gradually improving its gait.
There are many robots that can move well while executing a specific pre-designed task. But Hod and Josh's robots must start to learn by themselves from scratch in an unknown environment. It can sense its own progress, and like a baby learning to crawl, it becomes more aware of its body with every step and every tumble. Hod and Josh believe this self-awareness gradually builds into a basic form of consciousness.
Often we phrase the question, is something conscious or is it not? But it's really not a black and white thing. It's more about to what degree an entity is able to conceive of itself, to simulate itself, to think about itself, to be self-aware.
As robots learn to move in more complex ways, it's possible they will develop levels of consciousness equal to ours and maybe beyond.